So now this is a question from 5.8, but I thought it fit more with concavity. So given the graph, this is where we determine it graphically. For which of the following intervals is f of x concave up and f prime of x concave down? So first, let's determine when f of x is concave up. So this is the graph of f double prime of x. So we know that something is concave up when the second derivative is positive. So they try to trick you by showing you, oh, here's a nice little bowl where it's concave down and concave up, but it's not asking about f double prime of x, which is what this is. It's asking about f of x and f prime of x. So to find if f of x is concave up, we just look, when is this graph positive? When is it more than 0? So if we look from here to here, it's more than 0. So from A to B, I guess also at 0, but it's asking us A to B. That is when, I'll write this down. F of x is concave up from A to B, and it's also positive from D to E over here. So D to E, excuse my handwriting, because that's just when the graph is positive. So now we're looking at, so if the second derivative is, if this is the second derivative, if we have a first derivative function that's concave up or concave down, it's asking, then the second derivative needs to be decreasing, so getting smaller. So the derivative of f prime, that is decreasing. Oh, so that's going to be whenever this is negative, or whenever this is negative and decreasing. I think let's go to our answer choices. So we know f of x is concave up, which answers half of our question, from A to B and from D to E. That looks like toe, but that is D to E. So we can cross out anything that's not one of those. And now if we sketch our graph of f prime of x, we know that the derivative of the f prime of x is increasing on this interval just because the derivative of that is positive. So it would look something like up until B, and it starts going down, and then it goes back up. So it looks something like that. Not the best, but it's good enough. So if we look at this, it's concave down between this A and B because it's increasing and then it starts decreasing. So it goes from positive to negative at B. It's a point of inflection. So I believe that from A to B, it should be concave down. And yeah, it's just because if we sketch the graph of this, which is what this unit is telling us, we'll get to that in more depth in a second. Then we can sketch the graph and look and see, oh, look, this is concave down around here because the derivative is positive and then it changes to negative. So that's how you analyze concavity graphically. So now this is an actual sketching a graph problem. So if this is the graph of g of x, what's the graph of g prime of x? So remember that the derivative graphs the slope of a tangent line at any point on this graph. So if we look, it's decreasing, the slope is really, really negative, and then the slope goes to 0 at this point. So I'll draw the graph on top of here. This might not go well, but we can try it. So the slope is getting less negative until here it reaches 0 because here it changes direction, its derivative is 0. And then it gets positive for a little bit, and then goes to 0. Oh, wait. gets positive for a little bit, then goes to 0 over here. And it gets negative and then back to 0. And then it shoots off to, we suppose, infinity. So let's see which of these graphs looks like that. So two of these look very similar. They both look like this little graph that's stuck around here. But now we have to analyze, is this minimum of the graph on these, is that below or above the x-axis? So if we look back at my beautiful drawing here, it should be something like this. We know that the slope is 0. So the value of the derivative function would be 0 at this point. So if we look, if we want to line this up, it's a little bit harder when the graphs aren't lined up directly. But there should be a maximum a little bit greater than 1, and then it goes to 0 when it's a little bit, or yeah, it goes to, actually, I think part of this graph is wrong. And so then it's positive, goes to 0, and it's negative, goes to 0, and then it goes to infinity. Okay, so this little minimum should actually be below the x-axis, which matches up with this graph. And then the rest of it, you just have to sketch it out based on when is the original function increasing, then this graph that we draw should be positive. And if it's decreasing, it should be negative, meaning below the x-axis.